The previous video was getting too long. That is the reason why I decided to make a sub part for this second video tutorial. So we left at compare. Now we're going to begin with trim. All right. Before we do that, let us discuss the function that we missed out. All right. So consider a situation where we need to copy one string into another string. In Java, suppose we declare a string str bat and we assign str to str1. Well, this is perfectly legal. This is perfectly legal. This wouldn't give any problem in Java, but in C, this would give a problem because in C, strings are declared somewhat as constants. They can't be reinitialized. They can't be reinitialized. All right. So and as str doesn't refer a string as a whole, it refers to the address of the first element. So what we are technically doing is that we are assigning an address value here, but it wouldn't work in C. I'm going to show you that it doesn't. And so a solution to it is to be using the function called strcpy, which means a string copy. So the signature of the string copy goes as follows. The first string that it takes, the first argument that it takes is called the destination, and the second argument that it takes is called the source. So it copies everything from the source to the to destination. Alright, so this is how it is achieved. We declare a string here, we define a string here, and we are copying the contents of str to str1. That's it. Simple. Let's see that in action. Alright. So, okay. Alright. Okay. So I need another string for str3 for source max buffer cap. Okay, so strcpy str3 comma str1, and let's print str3. str3 equals percentile s str3. Oh. So let's run this. See, str3, the contents of str1 abc was copied successfully in str3. Right. So the next function that we have is trim. So what trim did in Java was that given a string, it would delete the leading and the trailing spaces in a string. All right. So there's no such function in C to perform this job, but we're going to implement it in C. All right. So let's see how that is done. Okay. So before I do that, I need I need to show you a very important observation. All right. So as I told you before in the previous video, that we can access any element in the string by writing the string's identifier followed by the index position. Now in Java, the string are not or should I what was that term? Well, I forgot that term. Well, in Java, a particular character in a string cannot be changed. It can be changed if I declare a string buffer. Well, that is a separate thing. But in a string, I cannot change a particular character. I cannot change a particular character at a particular index position. But in C, we can do that. In C, we can do that. All right. Now, for accessing the fourth element, we write the index 3. All right. Now, suppose we want to change this to a null character. All right. I'm going to tell you what do I mean with this. Alright, so I changed the fourth character of Batarang, which is A, with a null character. Now let's print it. Alright, so let's print this. Let's show what will be printed before. Isn't that less the like character and str, and let's see what will be printed after. Then str. We'll see. Before, the complete sentence of Batarang was getting printed, but the second time only the printf function only prints till back. Now what is happening? Well, printf function prints the string until it encounters a null character, and when it encounters a null character, it stops printing. So this is a very important observation that we require in designing the function trim in C. Alright, so let's get on developing that function. Alright, so trim would return the trimmed string. Therefore I'm putting car star as the thing. So I'm taking a string as an input, and just that, nothing else. I need nothing else. Alright, so let's design that function. Okay. Car star trim car str. Right. So first I need a pointer. For example, car ppr, which will initialize to null, as I stated before that a pointer must be initialized to null. So ptr equals str plus strlen. Str. So what am I doing here? I'm making my pointer point to the last character in the string. Alright, so the last character being the null character. Okay, so now, okay, I didn't discuss the logic. Alright, so what we are going to do here with this trim function. So from the observation that we made, we saw that on inserting a null character, the printf function only prints till that null character. Therefore, if we continue to insert null characters from after the string, like here, here, and here, and we stop when we get a character which is not a space, then printf function would only print the this particular set, the highlighted part. Therefore, using this logic, we can develop our trim function. Okay, so let's head on there. Okay, so now we need a for loop as usual. We don't need an initialization because initialization has already been done. And minus ptr greater than equal to str. Nothing here. And alright, if star ptr equal to space star ptr equal to a null character. I'm going to discuss what I'm doing right here. You don't need to get too much overwhelmed. Alright, great. Okay, we do need another string, car ret max buffer cap. Before doing that, I need to copy crcp1. Right. Copy this. Yeah. Alright, that's it. Okay. So what I did here. So star before the pointer. Means star actually means the value of operator. So what it does is that it provides us with the value present at the location ptr is pointing to. Now we can also change the value of that particular location by doing this kind of an assignment. So we were checking if a pointer was currently pointing to something whose value was a space. If it was true, then we were replacing that a space with a null character, and we are continuing to do this until we reach a character, until we reach the end of the string, or until we reach a character which is not a space. And in case it is a character which is not a space, we just break out of this iteration. That's it. So we are starting our for loop from the end of this string. So that is the thing. All right. So okay, let me just add some spaces here quickly. Okay. Now this, if I compile, will give an error. All right. So let's compile this. Gives us an error. Too many initializers. Now what does this mean? As I stated in my first video that there are different ways we can initialize an array. Now if in that matrix we initialize the array by 7 because we needed to accommodate that null character, but here there are too many characters, and that many characters is obviously greater than 10, so that is why I'm going to remove this, and it's going to compile fine now. See, there's no errors. Okay, I'm not using those values, no problem. Alright, so let's see. Let's just remove these lines, and okay, so let's see what's the before and after doing trim. Alright, so before this thing, okay, we're printing STR. Now we need another string, or we can just copy it there. str cpy str trim str. Now let's print that after name character %s name character str. Okay, to denote the spaces, I'm just going to use this 4 pins. Let's see that in action. Achha, I put that there by mistake. I'm going to remove that. Okay. So previously I had this many spaces, and now after trimming I am left with no spaces. So I was successful in removing the trailing spaces. Now what about the leading spaces? Well, I can do that even. I can take care of that even. So trailing spaces. Okay. Now I just need an array. A loop for str star str not equal to null if star str equal to space str plus plus else. Okay. So this is for the leading spaces. Okay. So what I'm actually doing here is that str, as we know, is a pointer. Str, as we know, is a pointer. Therefore, if the value of the pointer is a space, then I'm shifting then I'm changing the pointer by pointing to the next element. So thereby actually making the string small. And if I receive a character which is not a space, then I break out of it. So that's as simple that it gets. Alright, I'll just show an explanation for this. Okay. So let me copy the thing that yeah, let me copy this. Suppose we had 80 RA and there were spaces. Yeah. So we were successful in removing the in removing the trailing spaces. So I'm just going to replace the spaces by null characters. Fine. Now, okay, I need to copy that too. Okay, copy. Alright. So str. So if we consider the string as str first points to 1000. All right. Now we received a space. Therefore, we must move on to the next character. We must shorten our string. Therefore, on doing str plus plus, the value of str becomes 1001. Becomes 1001. We receive the space here too. Therefore, the value of str will become 1002, and finally, when str is 1003, it would stop. Therefore, we would be left with ARD. Alright, so let's see that in action. Okay. Okay, so and we are copying the thing as usual, as we have to return that string. So before and after. Okay, so let's run this. See, all the leading and the trailing spaces have been removed, so we were successful in creating and implementing the trim function. All right. Okay, so let's so there's one more function that I missed out. All right, so let's consider the situation. Okay, in Java, suppose we define the string, for example str equal to for example cars, and we want to change the value of str. We could directly do it using str equal to Porsche, for example, but we can't do this with strings in C. And for that matter, and for doing that, we have a function called sprintf. It's kind of like printf, but for strings. All right. So the what should I say? The signature goes as follows. The destination, the format string, and the arguments, and so on. All right. So let's see this in action. Okay. All right. So for example, we have background. Okay, let me just remove all the other codes because we don't need them anymore. Okay. Suppose we want to change, suppose str is batarang and we want to change it, to, what should I say, str equals, for example, cat, woman. Let's compile this. It gives us an error, L value required. So this can't be done. If we want to do this, we have to use the function called sprintf. So str is my destination. and what I want is to add a string. Therefore, I'm going to write cat common. Alright, so I'm going to print before and after as usual. Printf percentile s before str. Printf after str. See, before backrang and after cat common. So we were successful. And not only sprintf can work with strings, we can give anything here. For example, we want what should I say? A number, a string, a number again. We can do that. 1, comma 1. So it prints 1 cat common 1. So it is just a format string. Like the format we used in printf, we can use the same format here. But the only difference being printf works for printing out things to console and sprintf works for printing out things to a string. Alright, so that concludes the end of this part. So the next part would have the case study. So see you on the next one. Have a good day.